Welcome back to part 1 of episode 9, where we are continuing our journey to have a look at aggregate functions. In this second video, we're going to have a look at some of the more commonly used aggregate functions going forward and some of the more rare ones as well. So let's head on back into SSMS and continue the lesson. Count and count distinct. So what are we talking about with count? Is we want to count the amount of rows in a specific column that we pull within our scope. So here you can see in our where clause, we just want all of the orders for the order date of 2016, year of 2016. So that's cutting our scope down to just 2016 on the order date, and we just want to see the details for customer IDs in 1 and 2. So only for customer IDs 1 and 2. So we've narrowed down the scope of our select statement there, and we want to see it per customer ID. So what we're going to do with the first count is simply count the amount of order IDs within either the order lines or the orders table. We're inner joining on the order ID, so it doesn't really matter where we pull those from, either the order lines or the order table itself. Then what we're going to do is we're going to count distinct. Now all distinct does is it specifies we only want to count the amount of order IDs where there's no duplicates involved. So the count will count all the rows within the scope here and within each group. Count distinct will only count them once, regardless of how many times the same order ID is in the scope. Then what we'll do is we'll do the same for the order line ID, count distinct, order line ID, and we'll see what we get in our results. So let's have a look at that when we run it off. So for customer 1, the amount of order IDs he had was 26. However, the distinct was 8. Kind of order line IDs was 26. There were a total of 26 within that scope, and the distinct count was also 26. For customer 2, that's the same story, got 48 and 14 distinct. However, you'll see these are the same here. Now it might become a little bit more clear if we actually show you some of the data as well. So we're only going to look at customer ID 1. We're going to run the two off together, and you can see what's going on with that. Let's move this up a bit. So as you can see, here we have the customer order ID duplicated 5 times. This is because there are 5 different order line IDs. Now if you remember, the order line ID was a primary key column, so every number in there is unique. As you can see, it ascends going up, and there's no duplication for all 26 rows on the order line ID. And that is why you've got no difference between the count and the distinct count on the order line ID column, because all of these are unique anyway, and there's a total of 26 of them. However, when we get on the order ID column, things are slightly different. As you can see, there are 26 order IDs going down the list, because there's 26 rows down here. However, there's only 8 distinct ones, order IDs in there. So if we have a quick look, that's 1, 2, 3, 4, 5, 6, 7 and 8. So there's only 8 unique order IDs in that column. So that's what the count distinct does versus your standard count itself. As you can see, for customers 1 and 2, very different values there and there. However, because order line ID is already distinct, we get the same value there. So that's the difference between count and count distinct, and it all depends on the granularity, because here we're mixing orders which are unique orders. However, they can be broken down into many order lines, so we're mixing different grains there. And of course each order line may have a unique line ID. However, the order ID itself can be duplicated, as we've seen. So that's when you need to use your count distinct if you're asked for the distinct number of orders in a query where you're mixing different grains. Hope that all makes sense. Now, what happens with rows where there is a null value? So for example, when we're looking at left joining orders onto invoices, if we have the same scope, let's have a look at that when we run off this query here. As you can see, 29,885 rows in total. So if we did a count, we'd expect that amount coming back. However, bear in mind there are a few nulls creeping in there. So if we counted the invoice line ID, which we've got here as well, we expect 29,885, and we actually get 29,228. And that is because the count function and the count distinct pretty much ignores nulls completely. It doesn't count them. And in fact, that is the general mode of operation for all aggregate functions. They simply ignore nulls. So bear that in mind when you next write your count statement. It will not include a row if what you're putting within your function in these brackets, if they are nulls, it won't count them and add them to the total. So that's it for count and count distinct. Again, very commonly used functions, very straightforward and easy to use. Remember, don't forget the difference between count and count distinct. Very useful in certain scenarios, as we've seen there, and use those as you see fit. Okay, then let's have a very quick look at another small scenario. So the purchasing manager has just sent you an email requesting some data. She wants to know the following: how many purchase orders have been raised for each of our suppliers in 2016, and how many purchase order lines have been raised for each of our suppliers in 2016 as well. So we need to somehow count the amount of orders. If you think you can do this one, then pause the video, and when you're ready, we'll crack on with the answer from my perspective. Let's go for it. So we're looking at purchase orders, and we're looking at suppliers, and we're looking at purchase order lines. So looks like we need to bring in 3 tables there. First one though, I'll bring in the suppliers quickly. Where's our purchasing schema? Here we go. Here's our suppliers, and we need to bring in supplier name as S. So we've got our suppliers, fantastic stuff. We'll bring in our purchase orders. Supplier ID equals supplier ID. Easy money. Next, we have purchase order lines. As our purchase order ID equals purchase order ID. Fantastic stuff. So we have got our query all set up and ready to go. So we need to count how many purchase orders have been raised for each of our suppliers. Now, what we almost forgot was our filter here, 2016. So let's get that in quickly. And as far as I can recall, we're looking at the order date here from the purchase order tables. Fantastic. So let's bring that in then. Not forgetting our function. Seen before. So we're happy. We've got our query together. Now we've got to put some counts in order to check out purchase orders and the count of purchase order lines. So let's do that. And now we can either pull the purchase order ID from the lines table or from the orders table, and we should get the same results because we're inner joining. So let's take it from the orders table. And we also need the purchase order lines from the purchase order lines table, line ID. So we're going to do a count on those columns there because we know that obviously this one's unique, so we'll get the right amount there. So let's pull a count on those two rows, those two columns should I say. We'll call that total orders, and we'll give that a name of total lines. Alrighty, so we've got our counts together, put them all in. Let's give that a run and see what we get from there. And of course, once again, I've forgotten the group by, as you can see, very easily missed. But we're going to put that one in, and off we go. Alrighty then, so let's execute that. And you can see we've got 10 total orders and 10 total lines. So obviously we can have one order split between many lines. So we've got a slight problem here in so much that those two values are the same. So we've clearly got the total lines alright, but our total orders is slightly off, and that's because we need to use a distinct in there. Let's run that off again, and there you have. So there's 5 orders in total and split between 10 lines: 128, 708, 122 and 342. So straight away we can check out that we've got the right values using our count and our count distinct. So how did you all go? Did you get something along those lines? The same values as I did? If you did, brilliant stuff. Alright then, let's move on to some more aggregate functions, and we're just going to cover a few other ones that some of which are rare, and of course some of which we've seen and used many times before. We've got the sum and the average. You've seen those, and we've just done the count. So obviously the sum is like the sum function in Excel, where all it does is simply add together all the values in a specific column. Here we've got a little mathematical function multiplying that column by that to get a different result, and all the sum does is simply add them all together depending on the scope here. So it'll be all the ones from 2016 and all the ones that are in customer ID 1 and 2. However, we are grouping by the customer ID, so we'll get separate results for customer ID 1 and separate for customer ID 2. However, both will be from the order date year of 2016. So that's our scope in there, and we'll get the entire sum there. Average we've seen before. Again, we've used it once or twice, and all that does is simply sums up these columns here, whether it's a little formula, as you can see, sums up all the rows within the scope, and then simply divides it by the count of the rows. So you can see that in action here. We're summing it and we're dividing it by the count. So there's a little trick for you here. You can do count star, and that simply counts the amount of rows within your scope here. We've also got standard deviation and variance, which are two mathematical functions that are used in statistics, etc. They're all about a deviation from a mean or an average, and we'll run the query off, and you can see what's going on with those. Not forgetting the grouping by, and we'll order it by customer ID just to see what's going on there. There you have it. There's your customer ID 1, there's the sum. So that's everything in 2016, all added together, quantity time the unit price. Here's the average, and as you can see, when we manually calculated the average with these two functions there, we get exactly the same value. So obviously, just using one function is more efficient than using the two, with a little bit of mathematics thrown in there. Then our standard deviation, and you can see variance is quite a large number there. So, just a few more aggregate functions for you there. I've hardly ever seen or used standard deviation or variance, but they're just there to show you how to use those. Very, very similar to your sum, average and your count in the way that they're used. So that's it for aggregate functions. Hope you all enjoyed the first part there. We're going to have a look at windowed functions next. Until then everyone, I hope you all have a fantastic day.